This is section 5.2, inverse functions. And what we want to think about first is that some actions in the real world are reversible, some are not. For example, if you put on a coat and you go outside, you can reverse that. You would first come inside and then take off your coat. So there was a logical order of how you would reverse that. Mathematically, let's look at, all right, so in this particular example, we start with the operation 10 plus 5 equals 15. So you start with 10 and you add 5. And so the opposite, you would subtract 5 and end with 10. All right? So addition and subtraction are inverse operations. Same is true for multiplication. Start with 10, multiply by 2, you get 20. Then if you divide 20 by 2, you end with 10. All right, so let's look at this one. Subtract 7 from x and divide the result by 2. So if we put that in mathematical terms, we would have 7 subtracted from x. That would be x minus 7 and divide the result by 2. The inverse would be that we would multiply by x and add 7. So here, I did this on my calculator, and here's your original equation, x minus 7 divided by 2, and here is 2x plus 7. This line, y equals x, goes right through the middle, and all inverses are symmetrical about that line. So if you looked at something that was just a graph and you didn't know the equations, you could tell whether they were inverses by seeing whether they were symmetrical about this purple line. So that will be something maybe that we will see in our problems. Next thing we want to think about is one-to-one functions. Remember when we talked about the definition of a function, and part of that was talking about x can only be paired with exactly one y. Well, now when we know things are functions, we want to know if they're one-to-one functions. Can y only be paired with exactly one x? We had a vertical line test when we were talking about seeing whether something was a function. We have a horizontal line test to see if graphically it is one-to-one. So here's a picture. This is a function, but if I draw a horizontal line through it, it's not one-to-one. Here's another one. That's a function, but is it one-to-one? Yes, it is, because it only hits it one time when we draw that horizontal line. Okay. Now, the inverse notation is f with a -1 here, but that's called f inverse. And here's the steps for actually algebraically finding the inverse. We're going to replace the f of x with y if it's given in f of x terms. We're going to interchange x and y, because that's what happens in an inverse. The x's become the y's become the x's. We're going to then solve for y and then replace y with that notation f inverse. So let's do one here and see if we can follow those steps. So the first step says replace f of x with y. So we have y equals x cubed minus 2. Then we interchange the x and the y. So we have x equals y cubed minus 2. And now we're going to solve for y, which means I would add 2 to the other side. And then I've got y cubed, but I need that to be y, so I'm going to take the cube root of both sides. So I would end up with the cube root of x plus 2 equals y. And then the last step would be to change that y into f inverse. And you have found the inverse of our original equation, x cubed minus 2. All right. Think about this statement. since we reverse the x's and the y's, the domain of f equals the range of f inverse, and the range of f equals the domain of f inverse. So they literally just switch places. All right, let's look at this nice concept box about representing inverse functions. So we've got it verbally: multiply x by 2 and add 1. Subtract 1 from x and divide by 2. So symbolically, that one is 2x plus 1. To find f inverse, we did our little steps and we came here. To find it verbally, instead of adding 1, you subtract 1 and then divide by 2. So we've got that. Numerically, as you can see, the domain became the range became the domain. All right? And graphically, the same kind of picture that we had. Here's your 2x plus 1, here's your x minus 1 over 2, and here's that line y equals x. So that kind of just pulls it all together in 4 different ways. All right, let's look at some problems and see how we can do on those. All right, let's make this a little bit bigger. All right, consider the graph of y equals the cube root of x plus 2. Is this function 1-to-1? And we want to be able to draw let me pick that. So if I'm going to draw a line through here, and how many places did I hit? I hit just once. So that is 1-to-1. All right. Let's look at this one. And we saw this one kind of in our original notes, and we hit that thing twice, so that is not 1-to-1. All right. Now we're asked to look at a table and see if this f function is 1-to-1. So what are we going to be looking for? We need to remember that we said that y is paired with exactly 1x. Well, if we look here, this y value of 3 is paired with -2 and with a +3. So y is paired with 2 different x's. This fails to be 1-to-1. And what you're looking for, what you note, is that y is repeated. All right, on number 4, determine whether the function is 1-to-1. And we don't have a picture. We can easily go here to our calculator if you don't really remember what absolute value looks like. And second catalog, the first thing is absolute value. And inside that absolute value, I'm going to put x plus 3. And then I'm going to do a zoom 6 because I think I had changed my windows. All right, and so if I put that over here, and I draw a vertical line on any absolute value like that, what's going to happen? I'm going to hit it there and there, so that is not 1-to-1. Okay. All right, find a formula for the inverse. And we're going to do that with our little steps. All right, so it's f of x, so I'm going to make that be y equals 5x cubed minus 8. And then I'm going to interchange x and y. And then I'm going to solve for y. So I'm going to add x to both sides. I'm going to divide both sides by 5. And then I'm going to take the cube root of both sides. So over here, I have the cube root of x plus 8 over 5 equals y. And instead of writing that over with the f inverse notation, it's there. So this part is what you're going to put in the box. All right, let's do this one. We'll get some more room here. Okay, so we've got x squared minus 8. That's what y is equal to. And we're going to switch out and x equals y squared minus 8. We're going to add 8 to both sides. And we're going to take the square root of both sides. So we have square root of x plus 8 equals y. And so this is going in for f inverse. Get some room here. All right, so we have negative 1 over x. So instead of g of x, we're going to write y equals negative 1 over x. We'll switch out and have x equals negative 1 over y. To solve this, you actually can multiply y over here. So you're multiplying y on both sides. And then divide by the x. So you have y equals negative 1 over x. And so it looks odd that that is the same thing, that it could be the inverse of itself, but that is what we get. And so I actually put the box around the y, but that's what's going in there. All right, let's do this one. Get some room here. All right, so we're going to do the same thing here. We've got y equals 1/7 of 14 minus 8x plus 1. And we're going to change out x and y. I think there was a parentheses there. So x equals 1/7 of 14 minus 8y plus 1. Now we're going to try to solve for the y. Let's go ahead and distribute this 1/7. So we have 2 minus 8/7 y plus 1. You have a plus 2 and a plus 1, so x equals 3 minus 8/7 y. We need to subtract the 3, so we have x minus 3 equals negative 8/7 y. And we need to divide both sides by negative 8/7, which means we are multiplying, and I'll just actually write that one on here, both sides by negative 7 over 8. So our final part here will be negative 7 times x minus 3 over 8. And that would be equal to y, which is our f inverse. All right, so you have to think about what you're doing there. Let's do that for number 9. All right, so we have y equals 1/4 12 minus 7x plus 1. Switch out. So x is 3 minus 7/4 y plus 1. All right, so x is 4 minus 7/4 y. And then we'll subtract the 4. And we will divide by the negative 7/4, which means we're going to multiply by negative 4 over 7. And we will end up with negative 4 times x minus 4 over 7 equals y. And this is our inverse. All right. And we have one last one. So we have y equals 7x over x plus 2. So we've got a y a couple of places, x a couple of places. So then we have x equals 7y over y plus 2. All right, now we have to do a little bit of work here. So we're going to multiply both sides by this y plus 2. Over here, let's distribute. So we have xy plus 2x equals, and over here, those canceled out, so we just have a 7y. All right. Now, let's get this xy over here. So we're left with 2x equals 7y minus xy. Let's factor the y out. And since we're trying to solve for y, then let's divide both sides by 7 minus x. And so that's gone there. And we over here do have our final 2x over 7 minus x equals y. And that's what will be your inverse. And I think that will get you through 5.2.